Hey friends, thanks for tuning in to another video. Today we'll explore how you can use Valkey, the fork from Redis, as a key value store from within your Spin apps. That said, let's get started. Okay, let's have a look at the architectural diagram first. So the app is fairly simple, right? We have an HTTP trigger, our Spin app will be implemented in Rust, and it will talk to a key value store in order to read and write values. We will start by using SQLite in order to verify that our code works as expected. Then we will start Valkey using the Valkey container image locally and provide a runtime configuration file to connect our Spin app to our Valkey cache. Let's move over to terminal and let's start by creating a new Spin app using the HTTP Rust template. So we do a spin new -t HTTP Rust -a to accept the defaults, and obviously we provide a name for our new app. Let's move into the Valkey folder. That's where our app resists. And before we dive into code, let's add two dependencies. So let's use Cargo, the Rust package manager, to bring in the Serde crate using the derive feature. Once that's installed, we'll add Serde JSON to simplify creating JSON from Rust structs and to construct Rust structs from JSON. Okay, that in place, let's start the editor and let's have a look at the application manifest first. So remember, WebAssembly executes guest code in a strict sandbox environment, meaning we have to grant our app permission in order to use external resources. And one resource is also a key value store. So we update the component configuration over here and say we want to use key value stores. So we can use multiple stores, but for now we will stick with the default name for a key value store. If you call your key value store default, there is a convenient method provided by Spin SDKs to streamline interacting with the key value stores. You can use any name you want. Okay, let's move on to the implementation. We start by creating a new struct or model to lay out how our app should persist data in the key value store. So this is a struct called counter, which has a count property of type i32. And let's use the derive macro to bring in the default trait to make this struct serializable and deserializable, which simplifies the way of putting data into the key value store and reading data from the key value store. On top of that, let's create a simple const called key of type stir and set that one to counter. So this is the key that we want to use in order to store our data in the key value store and read it from there. Next, let's get rid of the default implementation over here and let's start by looking for the store. We use the store struct from the Spin SDK for Rust and we call the open default method. With the store in place, we can look for our counter, and because we want to increment the count, we define that variable counter as mutable over here, and then we can use store.getJSON and provide type information that we are interested in loading something of type counter from the key value store. There we go. Let's use unwrap or default over here. So we end up with a counter, right? If it is non-existing in the key value store, we get back a counter with the count 0. If there was something in key value store, we get back the actual value. However, we want to increment the count by 1 and use store.setJSON to set our counter again in the key value store. Last but not least, we want to construct a new HTTP response. So we can do that by using the response builder. So we want to return something with HTTP status code 200. Let's add a header, content type equals application JSON. And let's provide the body to be counter. So to make this work, right, passing counter to body, we have to implement the into body trait for counter. There we go. And we can simply use 30 JSON to back over here. To come up with a byte representation of our struct. Let's get rid of this. And let's get rid of this warning as well. Let's move over to our new terminal and let's do a spin build to ensure everything works as expected. Yep, there we go. So we can do a spin up. So this starts our app and leverages SQLite as a key value store. As you can see over here, storing default key value data to .spin SQLite key value.db, right? Move over to new terminal and we can simply curl to verify that the counter increases with every invocation. Great. Next step, we want to run Valkey on our local machine using the Valkey Docker image. So I'm using Valkey 7.2.5, which has been released a couple of weeks ago, and I configure port forwarding to, forward traffic reaching localhost on port 6379 to the corresponding port inside of the container. All right, next is moving back to our app, and let's bring up the tree and add a new file called valkey.toml, which we can use to wire up, right, to connect the Valkey container to our Spin app. So we want to configure key value store called default. We want to use a cache of type Redis, and that is accessible at redis://localhost. Let's save that one. Let's move to the other terminal, kill the Spin instance and do a spin up -- build and provide the runtime config file. There we go. So now our app is using Redis from the runtime config called valkey.toml. Let's move over to our third terminal instance and let's start curling the app again. Again, we have 6 as a count right now. And next, let's bring up a Redis UI to verify that data is actually stored within Valkey. So as you can see, I have already pre-configured a connection over here, which tries to connect to a Redis or Valkey instance running locally on port 6379. Let's open up the connection, and as we can already see, there is something stored in Valkey with the key counter, and it's set to the value 6. Let's do auto refresh over here. Let's bring that up there. Let's bring this one here, and let's start curling again. And as you can see on the right side, every 5 seconds, the UI reads the actual value from Valkey. That's it. right? It's that easy to use Valkey to fork from Redis as a key value store with your Spin apps. Are you using key value stores within your Spin apps? What are you building with the key value store? Let us know in the comments, right? And don't forget to hit that subscribe button. See you next time.